All right, so good morning, everyone. I welcome you to my YouTube channel. Presenting before you this test one physics revision is Hampel Clement. And to those of you that are new to this channel, just make sure that you subscribe, you also hit the like button, and also don't forget to share to others. So this is question one in a physics test paper, your revision. So make sure that even if you're from some other university, just go through so that you'll be able to get one or two things. Make sure that you grab the concepts as well so that you'll be able to solve almost every question in physics. So I'm going to start with the hard one, then I'm going to go to the simplest one. Okay, so I'll start with C, then I go to A, then I do B, because B is simply the easiest. All right, so let's get to the work. Okay, so this one is saying a projectile is thrown with a speed of 98 meters per second in a direction 30 degrees above the horizontal. Find the time of flight, the range of the flow, the height to which it takes. All right, so I'm going to do these questions slowly so that at least you grab something even as I solve. So for this question, they're saying a projectile is thrown with a speed of 98 meters in a direction 30 degrees above the horizontal. So the best way to solve this question, first of all, is to come up with some diagram. Okay, we're going to imagine a diagram. So I'm going to draw a diagram of this kind. So this is the first thing that you do. Okay, you draw a diagram like this. Okay, so I've drawn a diagram. Then, okay, so this is motion in 2 dimensions. To those of you that follow me, I'm sure you know what I'm doing. You know what I'm doing now. So they are saying that a projectile is thrown with a speed of 98 meters per second. So this is the motion of the projectile when it was thrown. Moved like this, then it dropped to this point. Then we have been taught that it took this motion with a speed of 98. So we can simply say that the velocity, which happens to be the speed, is going to be 98 meters per second, like this, 98 meters per second. Then we also have been taught that it was at an angle of 30 degrees. Okay, so this happened at an angle of 30 degrees. Now, just to make sure that everything is done well, it is better that we just come up with some data. Okay, we can come up with data. So our data is going to be here. Now, I can bring out almost everything that I will need in order to solve this question here. So I'm going to have an angle theta of 30 degrees. Then we have also been given the velocity of 98 meters per second. Then I know that my g, which happens to be my acceleration due to gravity, I know that it is 9.8 meters per second squared, like that. Now, I know that my Vx is simply 98 cosine the angle theta. My Vy is simply 98 sine the angle theta, like that. All right, so from what we have gathered here, we are able to solve the needful. They're saying we find the time of flight. Now, we know that y is equal to v y t minus 1 over 2 gt squared. I'm sure you remember this formula. Now, since we are starting from this point where this is 0, so this is going to be 0 equal to yt, this is v yt minus 1 over 2 gt squared, like that. I can divide everywhere by t, like this, so that I'm going to have 0 equal to, then this is going to be t, and t will cancel. I'm going to have vy minus 1 over 2 gt, like this. This can go this side. I'm going to have 1 over 2 gt equal to vy. Have you seen? If you cross multiply, you'll find that you're going to have gt equal to 2vy, then this over g, and therefore our time of flight is going to be 2vy over g, like this. So now, when you reach at this stage, you say t is equal to, now we know that vy is just the same as this vy here, so we can find this one. Now, to find this one, we're going to say that, so this is going to be 98 sine 30 degrees. So this is going to be 49. Okay? So 49. So we're going to put a 49 in here. 49 over 9.8. The time of flight, so this multiplied by this, simply 98 over 9.8, and therefore the time of flight is just going to be 10.0 seconds. Alright, so this was the time that it took for the projectile to move from here up to this point. Okay, we get to the second question, the range of the flow. Now they want us to find, because we know that the range is simply this distance. Okay, the range is simply this distance, the distance from here to here. Now the range is simply given by the formula. Range is equal to Vx multiplied by the time it would take from here up to here. Okay? So now, range, what is Vx? Vx is simply this one. So it's 98 cosine 30. It's going to give us, this is going to be 84.87. So it's going to be 84.87 multiplied by 10. It's going to be 8.7 meters. All right, so this is how you solve the first and the second question. Okay, first and the second question. First and the second question. Let's go to some other question. We do some other question. So the other one is simply saying that we find the height to which it takes. Okay, they want us to find this height from here up to here. Now to find this height, this is very simple. We know that the formula of use the formula of use, we know that the formula of use is simply, we know that this is going to be V squared, okay, this final, equal to those of you that follow me, I'm sure you know by now what I'm doing, if you follow this channel. Then this is going to be Vy squared minus 2, instead of putting A, we put G, then H. Okay? I'm sure you are familiar with this formula by now. Okay. Then we know that since we are starting at some point initial, therefore we are going to put a 0 here, equal to V squared Y minus 2GH, like this. This can go this side, so it's going to be 2GH equal to V squared Y over 2G over 2G. The height is going to be V squared Y over 2G. What do we do from here? Now, this is just the same as H is equal to, we have what is the velocity here, so we can say, now this Vy in the data, we had written it, it's just here. This is the Vy, this expression. So this is just the same as V sine theta squared. This is just the same as equal to V squared sine squared theta. Okay, like this. Then this is going to be, this is over 2G. Okay, this is just the same as V squared sine theta squared over 2G. Therefore, we can now put in everything. This is 98 squared, this is sine 30 squared over 29.8. Therefore, our answer, if we punch everything, so this is going to be, okay, let's find the answer. We see what we're going to have. Okay, 98 squared. Okay, divide by 29.8. All right, so our final answer is just 122. This one, 122.5 meters. That was the height. Okay, so that was the height. So if you do this, then automatically you solve this question. It's very simple. Let's go to A. A was simply saying that a car is traveling at a speed of 38 meters per second on an interstate highway, while the speed limit is 75 miles per hour. Is the driver exceeding the speed limit? Just find your answer. Now, these questions are just trying your mind, they're testing your mind. They just want to see whether you know what you are doing in physics. All right, so we know that the speed of travel was, accordingly to the question, it was 38 meters per second. Okay? But then we have been told that the speed limit was in miles per hour, and it was 75 miles per hour. So what we're supposed to do is simply this simply means that this person was traveling at 38 meters each second. So we will need to find the speed at which this person is traveling, considering this distance given that 8 meters in 1 hour. Okay, in 1 hour. So for us to find the distance this person covered in 1 hour, do you know what we're going to do? You just multiply this speed by 3,600 because those are the number of seconds that we have. So this is going to be, we're going to say that 38 meters per second is going to be multiplied by 3,600 seconds. Okay? But we know that this second and this second are going to cancel. And we're going to have 38 multiplied by 3,600. This is going to be 136,800 meters. So we keep this one. All right. Now, let's ask ourselves, how many meters makes up one mile? We know that 1 meter makes up 1609 miles. Those of you that did my conversion unit physics video, those of you that watched, you know what I'm doing. Now, I've converted this into miles. It is 1609, right? Now, let me try to divide this divide by this. I see, okay, because I want to see the speed that this person was traveling at, okay? I want to see the speed that this person was traveling at in miles per hour. Now, so I'm going to divide this by 1609. Divide by 1609. And the final answer is simply 85 miles per hour. So now, this person was traveling at 85 miles per hour compared to the speed limit, because the speed limit is 75 miles per hour. Therefore, the driver, okay, the driver is exceeding the speed limit, and he is, okay, just you put this just to show he is driving at 85 miles per hour. This was quite so much speed. Yeah, this was quite so much speed, almost like 10 miles per hour exceedingly. So this person was exceedingly, you know, overspeeding. Therefore, they we've justified that surely the driver was exceeding the speed limit. So this is how you do this question. For B, they're saying a car moves to the right. So this is just a motion in one dimension, right? Like this. The driver puts on the brakes. So this one, you have the initial velocity. They're saying the initial velocity is simply 15 meters per second. 15 meters per second. V final, they're saying it is 5 meters per second. The time we took for the brakes, it is simply 5.0 seconds. Okay, sure you've seen the question. Now, Okay, this is our data. We know that acceleration is equal to v final minus v initial over the time taken. So acceleration is equal to v final, it is 5 meters per second minus 15 meters per second over 5. A is equal to, okay, so this is just gonna be 10, negative 10 meters per second over 5, and therefore our acceleration is just going to be negative 2 meters per second squared. So this is how you find this question. It's quite simple, and I'm sure you've learned something. So don't forget to share, don't forget to follow my channel, and also share to others. So this is just how you do these simple questions. They are quite easy, very interesting. If you just follow them up, you practice them all, you'll be able to find almost every question that you'll be given in physics. So thank you so much.